Okay, cool. So,
Yeah.
I'll go first. Hi,
Okay.
my name's Yao. I'm a student at UT Charlotte. I'll be starting grad school this fall, and
Oh,
uh, my major was in computer engineering, and I'm switching to computer science. Um,
cool.
I don't have much work experience, just like mostly research. But yeah, I joined
So right
intern.club.
now, are you working anywhere?
I'm doing research right now for my school, but
Okay, in the college.
yeah, I'm not like working at a company.
So on which domain you're working? Like any specific domain related?
Uh, Kind of like cybersecurity and
Mm-hmm.
a mix of like natural language processing.
Oh, cool.
So, what about you, Mohan?
Yeah, I'm Mohan. So I'm a master student right now. I completed my first year in Houston. So right now I'm working as a software engineer intern at a company named Becht. So I'm working on C Sharp, ASP.NET, and some JavaScript for frontend. So this is my first job as well. So previously I don't have any experience. I came directly from my bachelor's degree from India and then directly jumped to the master's without any experience. Yeah, so tried for the internship from last 6 months and then got one finally in May. Cool. So and then yeah, I'll be graduating in next May. So I've started Leetcode doing stuff. That's it.
Um, so I guess I'll you can start with the first problem here.
Yeah.
Um,
So you're gonna solve it or how do
uh,
you want to go? Can I be like your interviewer?
Actually, I wanted to review you first because the only
Hmm.
reason I chose these two problems are these are the problems that I've solved before. So
I
I
mean,
actually
yeah. So I can be your interviewer then.
okay. I
So
mean,
yeah.
you could choose a different problem if you want, then, because
No,
I've
that's fine. Like, yeah, that's okay.
okay.
So yeah, let's see. Uh, So yeah, if you give an array as an input and a target, you need to return the indices where it will equal to the target. Cool.
Okay.
Okay. Yeah. So how would you solve it?
Um, Given an array of integers, trim with two numbers to add up to a specific target. You may assume that each input will have exactly one solution. You may not use the same element twice. Um, so I guess we're just assuming that given an array of integers, so I'm assuming that the array won't be empty. It will have at least one number in it.
Uh, Again, your voice is becoming low.
Oh, sorry. So I'm assuming that the array won't be empty,
Okay. Yeah.
since it says given an array of integers, so at
Mm-hmm.
least two numbers. Um, so I guess the brute force way
Mm-hmm.
would be to let's see here. We want to find two numbers that add up to the target. So you could just like do a double for loop, look at like the first element two, and then look at the next element. The next
Mm-hmm.
elements like 7, 11, and 15 in this example,
Yeah.
and then see if they add up, um, and get 9. But that would be like 11 squared 10 complexity, which is
Yeah.
not good. So another, so I believe the best time complexity here is like O of n, because you have to at least look through the array once.
Yeah.
The problem is like looking through the next couple of integers. Like, how could you look that up in
Mm-hmm.
like constant time or logarithmic time?
Yeah.
So,
Maybe you can just first write the code for brute force so that you may get an idea after seeing the brute force solution.
okay. So, open them. Okay, so, four. And then that's the one through section. Um, well, no, you don't want to start at 0 every time because, like, say you have, like, so 2, you check 2 and 7, 2 and 11, and then 2 and 15. But what we don't want to do is start at 0 and do like 7 and 2 because we already checked that here. So you would want to start where I is at. Think that. And then J would be less than. So that would check the rest of it. So the same thing. That's 5. And then goes to. And then we're checking if it equals the target sum. So if nuns I plus nuns J, that equals the target. And we're returning a vector. And I guess we would make another vector of we're gonna call it pair. And then I'll bless you after few
Excuse me.
but push that equal minus I into push that and J and then return okay. If it goes through this entire thing, it doesn't find anything. I guess we just return there as an integer.
So, can you see the test case here on the left side? So, whenever the target is equal, what are the things you need to return? I mean, in the example. So,
oh, the indexes.
Yeah.
Okay. I should have wrote the code. This is it, but
Yeah.
the time complexity is different. For loops. And then pushing back to a vector is constant.
Yeah.
So it's always in scope.
Yeah.
So somehow we have to make going through the second loop easier without having to iterate. So let me think here.
So,
I
do
think,
you have any idea about hash set?
yeah, I was thinking about using that.
Yeah.
So I'll try that out.
Mm-hmm.
I think I'm a bit unfamiliar with the syntax and stuff. I think it's unordered map. Let me see. Ordered map. Do you mind if I just look it up real quick?
Yes, yes. Even I don't know C++ that much, so
Yeah.
I use Java normally. Yeah, unordered map.
We need to get like a key and value code. So the thing with hash maps is that the lookup is in constant time. So we want to just make easier just to make our keys like the values we want. Make that integers, and then you could assign the values whatever. You don't really care about that. But just to make it like the simplest data type, I'll just make it true or false.
Okay.
And then I'll call that hash. So the thing with lookup is that we don't have to change like what we're doing here. Because initially we're going through a list and then adding them together to see if it equals the target value. But if we're just looking up that, if we're using the hash table to like look up the value and then add it, we're gonna have the same time complexity. So we want to just like see if the value we need to get to the target value is in the table. So say you have, so like, say the target value here in this example is 9, so x plus y equals 9. Then our x is the num, so like whatever value is in the array. So if it's like we're looking at 2, so we're looking for the y value, so like y is equal to n minus 6.
Yeah.
So in this case, whatever the num, whether it's 2, 7, 11, or 5, the lookup is 7 in the hash table.
Yes.
So the thing is that we need to return the array, like the index of that value. And
so
it's
instead of the
unsorted.
boolean, you can store the index, right?
The index.
So instead of every time making, like whenever you visit 2, instead of making it as 2 comma true, you can store it as 2 comma 0, which is 0 index.
Okay.
I mean, there it would be int, right? Int comma int.
Sorry.
Yeah, that's fine.
So if so we're seeing, is it in the hash table?
Yeah.
So is, I don't know, but I forgot to say.
Yeah, see.
Unordered map is value in, or is key in ordered map. Check the keys. Find double equals end. So I believe end is that means that like the key that you're searching for points to nothing in the list.
No,
So,
the other problem.
oh,
To some.
let me check.
Yeah.
Actually, so this means that the key that you're searching for, this will be nums points to nothing in the list.
Yeah.
That means it's not in the list. So if it is found on the list, you can just it is found. Then we would get, what does that return? That returns true or false. So then we would get the,
Yeah, if it is not there in the hash table, you need to add it, right?
yeah. I'm trying to see like what would we return if it is. Yeah. Return, push that. You would find the index.
First you need to add to the hash table, right? So if the hash table dot find nums is not there, you need to add that nums of I in the hash table.
So the key is nums of I. And the value. The keys have to be strings? No, it doesn't. And the value is I. The index.
Yeah.
Okay. And then we're retrieving the value. We're looking for that number in that index. That's the target. So we have I, so we'll push back like nums, or just I guess. But our, no, okay, sorry. So push back. So you need to return the indexes. So of the current one it's at, the current whatever it's at, which would be I, as well as the index of what was found in the hash table. So that would be hash table. No, I'm just going to make a variable called table value. So these would be the indexes.
So I mean you forgot to check one condition. So how do you know that when to push the I and table val?
How do I know when to do it?
So in line 10 and 11, you wrote that you need to push current index and table index, right?
Mm-hmm.
So what is the condition? When should it push the current index and table index?
Oh, okay.
Target.
I'm missing the logic of that.
Yes.
Yeah. So
I think you can write inside the if loop the condition.
target. Yeah. We're not looking for. We're looking for. I'm gonna target. Is equal to. So again, the target minus x. This is our x. So target minus and then target value is what we're looking for in the table. And the target value isn't in the table. If what we're looking for, then we push the parent and then the index. Does that make sense? Okay, so I'm gonna, I guess, test out this code. Hash table. Is hash table a keyword in C++? I should just name the table. Unordered. That's probably what it was. So let's see if this runs. Uh, 40 by 10. And then there's all. Oh, okay. Let's see now. Okay, it works. So the time complexity of this, the for loop is O of n. The table lookup is O of 1. I'm not entirely sure of the. I guess I'm not too good with hash tables. I'm not entirely sure. Like I understand that the lookup is O of 1, but is getting the value as well O of 1? Just, I think your mic is muted.
Yes, hash table, all things would be O of 1. So you're just running linear time, so it's just O of n num size.
Okay. But okay, so the one drawback of this would be it's O of n, but the drawback would be the space complexity because
Yeah,
we have to have our hash table map different
yeah,
values of, so it's O of n as well for the nums.
yes. It is also O of n.
One optimization, I don't think we get better time, but I think we get better space by.
But I think for this question, if you need to get the linear time complexity, you need to sacrifice space, I guess.
But there's one more way to do
Oh,
this, and it's basically using two pointers.
oh,
So you could have O of 1 times space and then or not O of 1, O of n times space and O of n time complexity and
okay.
one
Just a linear scan using two pointers like this, going towards each other and
right.
checking.
So you take both ends,
Mm-hmm.
you evaluate their sum, if the sum is too high,
Mm-hmm.
you move the right end inward.
Mm-hmm.
If the sum is then too low, you move the left one inward. And you continue like that. So you don't need to copy the array using the original array, but you travel in Elementine and then eventually hit the middle. I won't implement that right now. I think that
Yeah.
we have about 40 minutes left. So if you want to switch over and do the next problem, if you're
Yeah.
comfortable with that one. I can send the link in the chat if you want
Sorry, what?
do you want me to send a link to the Leetcode problem in the chat?
No. 1 second. I'll see. Valid Java palindrome.
You could choose a different problem if you want to.
Yeah, I got it.
I'm gonna stop screen sharing and then
Yeah. Can you enable the screen sharing for participant?
To be honest, I don't really know how to do that. What if I just make a shooter advanced sharing option? Oh, okay.
Yeah, got it. You see?
Yeah.
Yeah. Given a string, determine if it's a palindrome. Ignoring cases. Secor. And so in this question, do we consider spaces? Yes, I think we're considering the space as well. Okay.
Consider only alphanumeric characters in more cases.
Yeah, only alphanumeric characters. But I think in the example 2, you can see the space is also considered because of the space. Maybe I think.
It might be just the A.
Hmm.
Alphanumeric is just it might just be the A.
Sorry, what?
It could just be the A, like RACE versus RACA.
Okay. Yes. Yeah, got it. So yeah, I'm gonna code in Java. My first solution would be just like you, the brute force solution. So just checking the first and last pointer every time until they meet the midpoint. If they are not equal at any point, so we can return just false. So maybe I'll just code it. So the first step would be to making all to lowercase, which is this, and we have to consider only alphanumeric characters. So that would be to replace all other characters with just nothing. So these characters would be um,
Are you sharing the right screen?
sorry.
have like two monitors or something?
I don't understand.
Do you have like two monitors?
Yes, I'm seeing the big one.
Okay. I think you're showing the wrong screen. Let's see what you
Oh, s- yeah, can you see?
Yeah.
Yeah, before that I was just seeing all the options. I forgot that. So that replace one is not good one. I don't understand that one. So I think right now we can just check each one. S dot length. So every time we're gonna check caret. If the first character is equal to the caret, the last character minus one. So if it is not equal to the last character, so we can just return the false here. So if it come out of the for loop, it means it passes all the for loop. So we can just return the true here. So I think sorry. Yeah, I think we need to consider only alphanumeric characters. So
Right? There's like a built-in
um,
function for that.
sorry, what
There's probably like a built-in function for that.
function?
To filter out like only alphanumeric.
Yeah, so there is this replace character.
Right. I was just thinking for like commas or like any possible symbol they could throw at you.
Yeah, but I think I need to write a regular expression to avoid all the special characters. Um, maybe this one would work. S dot replace all. No. I think we just need lower cases and 0 to 9. Yeah. What is happening? So
Maybe
first
put
we
up
are
the screen.
taking the first, let's say s dot caret is equal to r, and then s dot length minus 1 is r as well. So both are equal, so it will go to the next step, which is a and a. So both are equal. Then c and c, and then e and a, which is false. So it will return false. Oh, I mean, for this example, maybe I can just print and see what is coming. Oh, a man, a plan, a canal, Panama. Yeah, so we're avoiding spaces, capitals, and symbols as well. So A M M N A P.
Is
Yeah.
what about what? I think you need to double check your if statement.
So every time it'll do the start from 0 and s dot length, let's say 15. Oh yeah. This pointer is not moving, so every time the length is 15, and then it'll be the 15 every time. So we need to divide that with I every time, so that 0 comma 15, and then 1 comma 14, and then 2 comma 14 minus 1, which is 13. Yeah, I think that would work. All this time this pointer is not moving, that's why it's showing the bad case. Yeah.
That's correct. So, what would be your time and space complexity of this solution?
Yeah, so this one is s dot length, so O of n, and space would be just O of 1, because we are not using any other temporary variables or data structures.
Okay.
So to optimize this, wait, it'll work or
Um, I think this solution is the most optimized way. Um, other than brute forcing, where you just do a double for loop. There is
Mhm.
another.
Yeah, there should be, because this is taking like 40 ms.
There is another solution to this that has the exact same time and space complexity with like tail recursion. Um, but it is the same. Like uh, its time complexity is O of n, and the space complexity is O of 1. So
Okay,
I don't know if you want
so
to try to implement that, but this is, in my opinion, this is more simple than trying to do it recursively.
yeah, but I think we can try the other thing as well, because this is taking like 40 ms for this question. So we can try, even though the other solutions are of n or of 1, we can try and think so that it would reduce the time complex this time. I mean, it would be of n as well, but this time we can reduce.
Yeah, it may converge to O of n, but maybe before you do that, it's O of n divided by 2 or something.
Hmm.
There could be more solutions, but those are the only three that I know of.
Maybe you can check. 271,
Wow,
3.
3 milliseconds.
Sorry, what?
3 milliseconds. That is.
This one is 3 ms. So first he's converting, removing all numeric and alphabetic, and then start and end points. So while start and end are equal less than, he is using char map. Okay, char map. I think this is not good to understand. There is no explanation. Char map. Yeah, this one would be good, I guess.
I'm not too familiar with car map or like.
Yeah. So char map, in the sense, it's just an array. The name is char map, array of 256. I don't know why they did 256.
Probably it's like some byte equivalent.
I think maybe we can see other solutions. There is no clear explanation.
It's like 8 bits.
Start. So yeah, I think this is also considered as for loop. So every time the start and ending pointers would be less than or equal to, and then he's just checking those two characters at the start character and the end character. If it is not equal to, it will return false, and every time incrementing the pointers. So just same as my for loop, but this one time complexity is 9 ms. I don't know why.
And maybe the regular expression. I'm not sure.
I mean, in this question or another question? I mean, another solution.
In our solution or your solution. Maybe that's. I'm not too sure what it.
Oh,
What
this
is.
one.
Yeah, I'm not replace all.
Oh, maybe that one would be.
Most of the time, people say.
Yeah, maybe we can try this one. So, every time character is letter order. Let's see. Yeah, replace all is off, and maybe we can try and use this function. So every time we have to check if s dot char at I not equal to the same one, and oh, yeah, I think this would work.
So where in that are you like storing the new string?
Storing what?
Right, like you're trying to filter out anything that isn't alphanumeric, right?
I don't understand.
Is that not what the function is doing? Isn't the function filtering out anything that isn't alphanumeric?
This one?
Yeah.
Yeah. So every time it is taking a character, right? So it will just check is it letter or digit. So if it is not, I think it will return true. Yeah. So if it is letter of digit, it would return true. And then if this is also true, so it will go to the next step.
Oh, okay, I see. It's doing it at
Yeah.
the same time.
Yeah.
That's a really usage.
Oh. So, um, I think we need to write exactly as he wrote. Where is it? Yeah, so we need to increment the pointer only if it is letter or digit, or else it won't increment. Okay, but still, this is not the optimal, I guess. Oh man, yeah, he didn't use the replace all function.
2 milliseconds. Wow.
So he wrote his own functions. Lower char is alphanumeric, and then yeah, this is almost kind of same, incrementing and decrementing the pointer. And if the lower case of left and right pointer are equal, not equal to, it will return false, or else at the end it will return true. I think it's best to use these. I mean, best to write our own functions instead of replace all.
Makes sense. Um, I don't know. I don't think an interview would be that harsh.
Sorry, what?
I said I don't think an interview would be that harsh to like see if like the runtime speed is quick enough or not.
Yeah, but they will ask probably, right? I mean, they'll definitely ask, can you think of other ways to optimize it?
Right.
So I think in December, I applied for internships and then I got this hacker rank for HPO. Um, so I wrote the test and luckily I got the interview. And then in the interview, he asked me the easiest question ever, which is like find the duplicates in the array.
Mm-hmm.
So I didn't expect at all. Like it's so much easy, right? So I mean, in the exam, they asked me a big question, and then in the interview, he just asked me to find if there are duplicates in the array, you need to return true, which means there are duplicates, or else false. So I was so happy, and then I wrote the code and I executed it. So it executed as well. But then he told me to optimize it, and then I tried some things, but it still is O of n square. So, and then, yeah, I got the reject. But after that, I realized if I can use the hash set, it is easily would be just O of n. So it's like every time you take an element, let's say 1, 2, 3. So every time take an element 1 and put it in the hash set, 2 put it in the hash set, 3 put it in the hash set. But before putting in the hash set, we can just write a if condition.
Mhm.
If the number is already present in the hash set, return false there itself. So it's like very easy step, right? Just involve one, it'll check and it'll return false. So then I realized the power of time complexity.
Yeah, I've been struggling a lot with like strings.
Yeah.
Like I didn't realize like concatenating strings
Hmm.
is OOM as well. Like because it loops through the what you have to fit like the
Yes.
newest character as well.
Yeah.
So like a lot of the built-in functions can throw you off if you don't really look into them.
Yeah. And also, I think this one. What is this? Uh, I forgot. Yeah, the base case and the every cases, the edge cases we need to write. So every time when we're starting the program coding, so at the first step you need to write the base cases. Let's say like if your input parameter is an array, so you need to write if array dot length is less than one, or if array is null, return null. So those are like base cases, right? So that one I realized that for every program you need to first start with the base case. That would be so good. And then yeah, so back then I didn't practice much, so now I've started. Just whenever you see a question, try it in a brute force way and think of some other solution, and then see the discussion group, so you can find all these different answers, and whatever answer you can understand by reading them, you can try and practice that answer. So this is the way I'm following right now.
What do you use to study? Are you just using Leetcode?
Using what?
Are you just using Leetcode to study?
Yeah, like right now, Leetcode, but whenever I need to see the concepts, I'll just Google it. Like, let's say I want to see linked list, I'll just Google it, linked list, and see Geeks for Geeks or any other website randomly. Yeah, I'm basically good enough. Like, I can understand all the concepts easily, but the only problem is to code it.
Right. And
Yeah,
like,
because
knowing when to apply what
yeah,
to optimize.
so like everyone knows basic, right? So let's say stack, you can input insert the element from top and remove the from the top. So those concepts everyone knows, but where to use what is the thing.
Right.
Yeah. So for that we need to practice maybe 2-3 months
Yeah.
to get at least to get to a beginner level at least maybe.
Okay. I think you did a good job like describing what you were doing.
Yeah, but still this is, I mean,
I think
still I couldn't optimize.
right. I think you like. I was a little thrown off because you like your initial solution was like at least in like a time complexity wise was like
Yeah.
the most efficient. Um, I'm always confused. Like, do I intentionally just use a brute force at first, just like a
Sorry,
straight?
sorry. What?
Should I like intentionally like enter interviews? Like, this is the question I'm always wondering. Like, should I just intentionally do the brute force on purpose just to show the
Uh,
progression? Like, if you have time, or should you just jump straight into the best solution that you can think of?
yeah, but I think maybe brute force would be good approach because so in an in interview, let's say like you're talking with the interviewer, you can tell your brute force solution. But if the let's say the question is small, you can just code it and show him the brute force solution and try to optimize from that code. Right? Like if the question is too long and the answer is too long, then it's like time waste.
Mm-hmm.
But let's say the question is okay, like you can code it within like 1 or 2 minutes, so you can write the brute force solution and explain to him, and from there you can tell him to how to optimize that brute force, so he'll understand it more clearly, right, by seeing your brute force solution and also how you're optimizing it. So I think that would be good for normal questions, so that's why I always consider it like that. I'll write the brute force so that I can understand and the interviewer can understand what you're thinking at first after you see the question. Yeah. And then, yeah. And from that solution, you can explain to him clearly that so you have to optimize this. So I'm using two for loops there. So it is the brute force. And I want to use it to get O of n, which means I have to remove one for loop. Like you can see the code and you can tell him the changes or how you are optimizing it. So it's best to write the brute force, I guess, in my opinion.
I also struggle with like, what questions should you ask? Like for like the actual
Okay.
problem, like is the array empty?
So questions would be, yeah, let's say if you're getting an array as an input, you can ask like, so can the array be null? Like you can't say like, so when I got that in HVO, so I prepared to how to ask questions, and then the first question I was so confused and I asked, so can I assume that array is not null? And he told, I didn't say you can assume. So so I mean you can say that, but you can at least ask like, so is the array can the array is null or it should always contain the elements? So he can answer you. And can the array elements be always greater than zero, like positive numbers, or it has negative numbers? And yeah, can the array be always sorted or unsorted in the specific question? So in the question you got the arrays 2, 7, 10, 11, right? So that seems like a sorted thing, but there may be other test cases which are not sorted array. So we never know, right? So that question we need to ask the interviewer: can the array be always sorted or no?
Right, that's an important part that I
Yes.
didn't explain. Was
Oh,
that
that's okay.
that solution only works if the array is sorted. If
No,
it's
I think your solution works
well,
even though
actually,
it's
maybe
not
not.
sorted.
No,
Yeah,
yeah,
your
you're right. It is
solution
just fine.
is using the hash map, right? So it will work even if the array is not sorted. You just have to ask the question. That's it to the interviewer.
No, I was talking about the ones with the two pointers moving in. I
Oh,
think that works as well. I don't
mm,
remember. I solved the problem yesterday where like I don't remember what problem. It may have been a different problem, but like
okay.
in some cases, though, you need to sort the list before you do that.
Yes.
Yeah.
So yeah, those kind of questions would be good, I guess.
Okay.
And whenever you see the array input is sorted, maximum like you can try to get it to the O of log n. So there is always like whenever you see the array sorted, think of a binary search way of solution. Because I saw that whenever the array is sorted, you can always think and remodify the binary search algorithm, which will get you to the O of log n. So that's one thing. Mm, yeah, that's it. And hash map and hash tables are more important as O of one.
Great. Okay. I think this was a pretty good session. Uh,
Yeah.
well, good luck in your future interviews, and it's been great talking to you, Mohan. Am I pronouncing your name right, Mohan?
Sorry, what?
Am I pronouncing your name right, Mohan?
Yes, Mohan. Yeah, yeah.
All right, cool. Well,
Okay then.
have a good one.
Cool. Nice to talk to you.
You too.
Yeah. Bye bye.